I'll be talking about how we can save cost in our logging for our application logging, where we can save almost like 60 to 70% of our current cost if you are following the strategy that I'm mentioning like in the next slides. So this is me, like my name is Ramdev CM and I work at an academy as an SRE platform engineer, and I like passed out at 2022. So you can scan if you want to connect me via LinkedIn. And if you have any queries, like if it doesn't get over here, we can connect over LinkedIn also from outside. So the architecture is something like we'll be collecting the logs from like container level from Fluentbit, and we'll be passing it to Fluentd. Then Fluentd will be passing it to like where we want to visualize it. Let's take OpenSearch as an example here. OpenSearch, we can also use Elasticsearch as well, but we'll be taking OpenSearch as an example. So this is like a fancy model of like Fluentbit image that I got from internet. So the sources are like, we have a lot of sources where we can use Fluentbit, and destination also, like we have a lot of destinations where we can deliver the data collected by Fluentbit. And this is the Fluentd like kind of image. So the same like the source and destination for Fluentd is also like somewhat similar, where it can collect application logs from various like data sources, and it can like send those logs in JSON format to the destination like servers. And what is the difference between like Fluentd and Fluentbit, or why we are using like two applications where the use cases are somewhat similar? Both will collect the logs and it will send to the destination, but why are we using these two or combination of these two? So you can like go through these points, but the main thing that I want to point out is it's like the Fluentd is a bit heavy and Fluentbit is lightweight. So if we check its container, like its image or whatever, it will be lightweight for Fluentbit, and Fluentd will be a bit heavy. So we can run Fluentbit as a daemon set in like every node, so that it will collect the logs from all the containers or whatever we are specifying it as the like input from where we want to get the logs, and it will like send the data to Fluentd, and Fluentd will be like less in number, and Fluentbit will be running in all of the nodes. So basically Fluentd will do certain operations that I will share in the next slide, and it will send the data to OpenSearch. That is the main like difference, or why we use these two components. And this is like a simple like high level diagram where we can architect our logging strategy. So we will be having Fluentbit running on our pods, sorry, on our like nodes, and it will be collecting logs from container level or like pod level or whatever, from wherever we want to like collect. Then it will be sending to Fluentd, which runs on an instance or which runs as a stateful set or whatever like we are defining. Then it will send those logs to our destination. Let it be like Elasticsearch, Kibana, like Influx, Grafana, or OpenSearch, wherever we want to send it to. Also I mentioned like what all happens like in every phases. So in Fluentbit side it will collect the data, it will just collect the data, and in Fluentd side it will aggregate the data and process the data, like transforms the data to various forms in which format we want to, and so on. Like, and in the other case, like we can index the data or whatever we want to, then we can like visualize the data, visualize the logs or data we collected. Then the deployment, like everyone might know how to deploy like a stateful set or daemon set in Kubernetes cluster. We'll find the Helm chart. We can do Helm chart deployment, and if it's an EC2 deployment, basically we can install a like a TD agent, basically the agent in that particular instance. So you can just go through this doc if you are going to install, go through this link if you are going to install it on your systems. Now comes the working. So I mentioned like we are using a combination of Fluentbit and Fluentd. So the working will be like Fluentbit will collect the logs, then Fluentd will aggregate the logs and transform the logs and send it to the destination. So like Fluentbit acts as a collector and forwards what was designed with performance in mind, as described above. Like we are focusing mainly on the like performance of the application. So if you run Fluentd on like node level, it can affect the performance of the system or the application because it's heavy weighted. So we'll be running Fluentbit on node level. Then Fluentd was designed to handle heavy throughput because the architecture is like that, it can handle heavy throughput, and it can like collect the logs from multiple inputs. So that is also one of the advantage of FluentD. Then one disadvantage of FluentBit is that it does not have much plugins where we can like aggregate or transform the data. That is why we are using FluentD to aggregate the data, and FluentD have like more number of plugins and other features. Now like we have the data, and where can we view them? So there comes like the application of like OpenSearch or like Elasticsearch and Kibana dashboards or Grafana with Loki, and there are a lot of other things too. So I'll be explaining AWS OpenSearch. Basically we have open source OpenSearch as well, and I'll be explaining mostly AWS OpenSearch because in like most of the startups and other like places we will be using AWS managed services. So the architecture is something like we'll have like I'll take from the VPC level. We'll have the application load balancer, and it will have the data nodes, then ultra warm nodes, then cold storage and master nodes. So master node is not like mandatory for the OpenSearch to run. So if we ignore master node, there are certain issues or challenges that we will need to face, and if you have data nodes, we need at least we need data nodes to run OpenSearch. So basically the FluentD will be connecting to the ALB, and the endpoint or the URL whatever we are specifying, the host URL that we are specifying, and that they will be connecting to the data nodes, and data nodes will be helping to view the data. So there are certain terminologies that you can refer, and yeah, sharding is also one concept that we can refer in OpenSearch. And now where can we save the money? Basically we will be having a node, and within node we will be having names like within all the namespace we will be having like the pods, and inside pods we will be having containers. So from containers will be like FluentBit will be collecting the log from all the containers, and it will be sending to FluentD, and FluentD will be sending to OpenSearch. So in this case FluentD will send all the logs in container level. It will index the logs in container level and it will send. So basically it will create almost like 60 shards per namespace if this is the architecture, like 16 container. So it will create 60 shards, and one data node can only handle 1000 shards. So basically if the number of shards increases, there will be an issue with like our OpenSearch cluster, and it can go to like there can be downtime or the issue for the cluster, like health for the cluster. So to save that, basically what we can do or what we have implemented was basically to send the logs in namespace level. We will collect the logs in container level, then we will aggregate the logs in namespace level, and we will send it to the OpenSearch, so that we can reduce the number of shards from 60 to 1. So these were the like code change that we have done, and you won't like notice much difference, but you can see the log/prefix part where we have sent prefix, then namespace, then container, but in the new FluentD config where we have saved the money, we have just passed like prefix and the namespace. So that is it. This was a short talk, but I took some more time. So if you have any questions, we can discuss like further. Thank you so much.